Hey boys and girls, today we're going to talk about types of errors, affectionately known as type 1 and type 2 error. We're going to look at what these errors are, how they tie to a concept called power, and we're going to look at the interrelationship between them. A lot of little theory in here, so be careful and take very good notes. Pause whenever you need to write something down because you're going to need these notes for the quiz the day we get back. Just like the judicial system, which makes mistakes, hypotheses tests can also make mistakes. For example, well, I guess let's start off thinking positive. A good thing would happen if the null is true, we shouldn't reject it. So a good thing to happen would be that we would correctly fail to reject the null. If the null is false, the correct decision would be then to reject the null. But sometimes, boys and girls, the null is true and we make a mistake and reject it. This is called type 1 error. And other times, the null is false and we fail to reject it. This is called type 2 error. So to conclude, type 1 error, we reject the null hypotheses when it's true. Type 2 error, we fail to reject the null hypotheses when it's false. An example. The null in a trial would be a person is innocent. The alternative would be they're guilty. What would a type 1 error be? Think to yourself, a type 1 would be rejecting the null when it's true. So in other words, we would say that the person is guilty when they're innocent. A type 2 error would be where we fail to reject the null when it's false. In other words, we say they're innocent when they're guilty. I remember the difference between these two types of errors by always remembering that O.J. Simpson is the epitome of a type 2 error. Which is worse here? I guess it depends on who you are. If you're the guilty person getting off, you think that's pretty good. But the community might say, hey, this is bad, at another time because all these guilty people are getting off. Or you could be the innocent person who's going to jail. Now, a very important concept is called power. Power is the probability you reject the null when it's false. In other words, you do the right thing. You reject when you should. So in this case, power would be we say the defendant is guilty when they are guilty. Or better put, it's the likelihood that we say they're guilty when the defendant is guilty. Here's one for you to try. Null is someone's healthy. The alternative hypothesis is that someone has a disease. What would be a type 1 error, type 2 error, and what is meant by power? Which is worse? Pause this video, write down your answers, and then we'll check. Welcome back. A type 1 error would be determining that a person has a disease when he doesn't. A type 2 error, determining that a person is healthy when he actually has a disease. And the power of the test would be the probability that you tell the person that they're sick when they really are sick. Which do you think is worse here, the type 1 or the type 2? I personally think definitely type 2, because if you think you're healthy, you're not going to be taking any medicine that you need to take. Upwards and onwards to the wonderful world of potato chip manufacturing. Here's the deal. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the entire truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. Yay! To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will perform a hypothesis test using the following hypotheses. The null, the true proportion with blemishes is 8%. The alternative, the true proportion with blemishes is greater than 0.08? Stop the video and answer the 3 questions. What's type 1? What's type 2? And what do we mean by power? Type 1 would be you determine that more than 8% of potatoes have blemishes, and incorrectly, goodbye truck, send it away. What would type 2 be? You failed to reject the truck and actually use the shipment when they have blemishes, and then we all get stinky potato chips. Power would be correctly sending the truck away, or the probability that we correctly send the truck away when more than 8% of the potatoes have blemishes. On the following page, you see a picture that helps us sort of understand the type 1 error. If the null is true, our distribution of p-hats would be centered at the true value 0.8. Sometime before the test, you determine an alpha level. Remember, that said is that if we get a test statistic smaller than alpha, or that's less likely, we're going to reject the null. So if we set alpha, say, at 5%, then if we get a p-hat that happens less than 5% of the time, we're going to reject the null, even if the null is true. So basically, everything to the right of your alpha, you would be rejecting the null, even though in this case, the null is true. Now we can also consider the case that happens that not only could the null be true like in the top picture, but maybe the alternative is true like in the bottom. And in this case, your p-hats would all be centered at a different value, say 0.100. You've already set the alpha with this green line, and now let's say you get a p-hat to the right of that line. Well, the null is false. If you're to the right of this line, you're going to reject when you should, and that is called power. But if your p-hat comes to the left of this line, you're going to fail to reject. Remember, on this bottom picture, the null hypothesis was wrong, so failing to reject would be bad. So on the left of this line, we'll see type 2 error. We're going to sum it all up really dynamically here by looking at the following picture. We're going to start off with the upper graph. This is that the null is true. You set an alpha level. If your p-hat is less than alpha, in other words, its likelihood of happening is less than alpha, then you're going to be rejecting the null. So any p-hat on the right of this line is going to happen less than alpha % of the time and will cause you to reject the null, even though the null is true. So if you make alpha bigger by going to the left, you're rejecting more often when you shouldn't. And if you go to the right, alpha is getting smaller, you're rejecting less often when you shouldn't. So basically, conclusion number 1, the alpha level is the probability, oh wow, I lost a y at the end of probability in the box, of making a type 1 error. This is huge. When you set your alpha level, you're basically saying that even when the null is true, I'm going to reject that percentage of the time. Now the bottom graph, we look at the case that the null isn't true and some alternative is true. Now, if you get a p-hat to the right of your alpha line, you reject when you should. Everything to the right here is considered power. If you get a p-hat to the left of this line, well then you're going to fail to reject even though the null is false and the alternative is true. This is type 2 error. Notice that type 2 error and power make up the whole curve. So in other words, the probability of a type 2 error and power will always add up to 1. Now, it's interesting to watch here, but I want you to focus on the relationship between type 1 and type 2 errors. If I make alpha smaller by moving the green line, my alpha level, to the right in the top picture, what's happening to type 2 on the bottom? And if I make the alpha level larger in the top by moving to the left, what's happening to the type 2 error? I think you can see as type 1 decreases, type 2 increases, and vice versa. So conclusion 3, as type 1 increases, type 2 decreases. Okay, the next kind of conclusion actually makes a lot of sense. I want you to say to yourself, when am I likely to reject the null when I should? When something's a little wrong or a lot wrong? Well, in the case, let's just say the null is really, really wrong. So the alternative would be really different. The more different the alternative is, you could see that the power on the bottom of the graph is getting larger and larger. And that's because the more wrong something is, the more likely you are to recognize that it's wrong. So our next conclusion is that the more wrong the null is, the larger the power is. The last conclusion is that there is one secret way to make type 1 error go down and make type 2 error go down and increase the power. Any guesses? Well, it is, drum roll please, you increase the sample size. Think of it logically. If you sample more people, you have more information, you're less likely to make any mistakes, and you're more likely to reject when you should. So this picture that we've looked at up here is a real key diagram of how type 1, type 2, and power interact with each other. To conclude one more time, the alpha level sets your type 1 error when you're going to reject even though the null is true. And if you look at the picture, as you make the alpha level bigger, the type 2 error gets smaller. And remember that type 2 and power always add up to 1. Read the reading in the book and try the problems, and I think you're going to be great.